Hello gardeners, welcome to the Living Soil Lab. Have you ever tossed leftover rice into your compost bin or garden bed without giving it a second thought? Most of us assume that organic matter is organic matter, and it all breaks down the same way eventually. But what if the form that rice takes when it enters your soil determines which microbial communities it feeds, how quickly nutrients become available, and even the long-term structure of your soil? Today, we're diving into a fascinating comparison that reveals how raw and cooked rice create completely different biological responses in your garden, and understanding these differences can help you strategically feed your soil ecosystem for specific outcomes. The chemistry behind the forms. Why processing matters. Raw rice is essentially a compact package of starch protected by a hard outer layer that resists water penetration and microbial attack. The starch molecules are tightly organized in crystalline structures that require significant enzymatic effort to break down. When you add raw rice to soil, you're introducing a slow-release carbon source that will persist for weeks or even months, gradually feeding microorganisms as they work to crack open these resistant granules. The hardness and structure of raw rice means that only certain microbes with powerful enzyme systems, particularly fungi with their extensive networks of mycelium, can effectively colonize and decompose it. This creates a fundamentally different biological scenario than what occurs with cooked rice. Cooking rice transforms it at the molecular level through a process called gelatinization. Heat and water cause the crystalline starch structures to swell and break apart, creating a soft, easily accessible food source. The protective outer layers become permeable, and the starch molecules reorganize into forms that are immediately digestible by a wide range of soil bacteria. When cooked rice enters your soil, it's like ringing a dinner bell for bacterial populations. The rapid availability of simple carbohydrates triggers an explosive burst of bacterial growth, fundamentally different from the slower, more fungal-dominated decomposition of raw rice. Understanding this distinction allows you to strategically choose which form to use based on whether you want to stimulate bacterial activity for quick nutrient cycling or encourage fungal development for long-term soil structure building. Raw rice. Building fungal networks and soil structure. When you incorporate raw rice into your soil, you're essentially planting seeds for fungal colonization. Fungi excel at breaking down resistant materials through their production of powerful enzymes and their ability to physically penetrate tough structures with high-fall threads. As fungal mycelium spreads through the soil to colonize raw rice granules, it creates a three-dimensional network that binds soil particles together, dramatically improving soil structure and creating stable aggregates. These aggregates are crucial for maintaining pore spaces that allow water infiltration and air penetration while preventing compaction. The slow decomposition of raw rice means this structural benefit develops gradually, but persists over time as the fungal networks mature and strengthen. The microbial succession that occurs around decomposing raw rice follows a pretty predictable pattern. Initial colonizers are typically molds and fast-growing fungi that begin attacking the outer surfaces. As decomposition progresses, more specialized fungal species move in, along with bacteria that feed on the byproducts of fungal metabolism. This creates a diverse, balanced microbial community rather than the bacterial bloom that cooked rice produces. For gardeners focused on building long-term soil health and establishing robust fungal networks, particularly in areas where you're growing perennial crops or establishing new beds, raw rice offers distinct advantages. The slow nutrient release also means less risk of nutrient loss through leaching, as the gradual breakdown allows plants and microbes time to capture and utilize everything the rice provides. Cooked rice. Igniting bacterial activity and quick nutrient cycling. The moment cooked rice hits your soil, bacterial populations begin multiplying exponentially. The readily available starches and sugars provide perfect food for bacteria, and within days, you'll see white bacterial colonies appearing on rice particles if conditions are moist and warm. This bacterial explosion serves several valuable purposes in the garden. First, it rapidly cycles nutrients, making them plant available much faster than slow fungal decomposition. Second, the bacterial metabolites and cellular material that result from this growth spurt create a flush of nitrogen and other nutrients that can give plants an immediate growth boost. Third, the intense bacterial activity helps suppress certain soil-borne pathogens through competition and the production of antibiotics and other defensive compounds. However, the rapid decomposition of cooked rice does present challenges that require management. The burst of bacterial activity consumes oxygen quickly, and if cooked rice is added in large quantities or isn't adequately mixed into soil, anaerobic conditions can develop. These oxygen-depleted pockets produce foul odors and can actually harm plant roots and beneficial organisms. The solution is straightforward. Always bury cooked rice at least 4 to 6 inches deep in soil. Mix it thoroughly with existing soil rather than clumping it, and never add more than a thin layer at once. Covering buried cooked rice with a carbon-rich mulch like leaves or straw helps balance the high nitrogen content and maintains aerobic conditions. When managed properly, cooked rice becomes a powerful tool for quickly energizing depleted soil and providing a burst of biological activity that can kickstart nutrient cycling in areas where microbial populations are low. Observing the differences, what actually happens in garden beds is, pretty fascinating. The contrasts between raw and cooked rice applications become visually apparent within just a few weeks when you observe them side by side. In beds amended with raw rice, changes occur gradually. You might notice increased fungal activity, visible as these white mycelial threads in the soil, especially around the areas where rice was incorporated. Soil structure improves steadily, becoming more crumbly and less prone to compaction. Plants growing in these areas often show steady, sustained growth rather than dramatic spurts, and, honestly, the soil retains its improved characteristics for months after the rice has fully decomposed. The fungal dominance created by raw rice decomposition is particularly beneficial for crops like tomatoes, peppers, and fruit trees that really thrive with mycorrhizal associations. Beds receiving cooked rice show more immediate and dramatic responses. Within a week or two, you'll often notice plants displaying darker green foliage and accelerated growth, as the rapid nutrient cycling delivers a pulse of available nutrition. The soil biology shifts toward bacterial dominance, which benefits fast-growing crops like lettuce, spinach, and other leafy greens that prefer the higher nitrogen availability that bacterial decomposition provides. However, these effects are shorter-lived than those from raw rice. The cooked rice is typically fully decomposed within 4 to 6 weeks, after which the bacterial populations crash back to baseline levels. This makes cooked rice ideal for giving struggling plants a boost or preparing beds for immediate planting, but it's less effective for building lasting soil improvements. Strategic application, matching rice form to garden goals, really comes down to understanding these biological differences, so you can use raw and cooked rice strategically throughout your garden. Use raw rice when establishing new perennial beds, preparing areas for fruit trees or shrubs, or building soil structure in compacted areas. Incorporate it into the soil in fall, so fungal networks have time to develop over winter, creating improved structure ready for spring planting. Raw rice is also excellent for creating fungal dominance in beds where you'll grow crops that benefit from mycorrhizal associations. Apply it at rates of roughly 1 cup per 10 square feet, mixed thoroughly into the top 6 inches of soil. Reserve cooked rice for situations requiring quick results. Use it to revitalize tired soil between successive plantings, give transplants an establishment boost, or energize areas where bacterial populations have crashed due to chemical inputs or compaction. Bury small amounts of cooked rice around individual plants that need a nutritional pick-me-up, or incorporate it into compost piles to accelerate decomposition of other materials. Never exceed 1 cup of cooked rice per 10 square feet in a single application, and always make sure it's well buried and mixed to prevent anaerobic conditions and pest attraction. The broader lesson here extends beyond rice to all organic amendments you might add to your garden. The form, structure, and processing state of organic materials fundamentally determines which microbial communities they feed and what soil outcomes they produce. Fresh versus dried, raw versus cooked, whole versus chopped. Each variation creates different biological responses. By understanding these dynamics, you move from randomly adding organic matter to strategically cultivating specific microbial communities that serve your garden goals. Subscribe to the Living Soil Lab for more explorations of soil biology, strategic amendment applications, and the science behind building truly living soil. And hey, share your own raw versus cooked rice experiments and results with fellow gardeners eager to understand the invisible world beneath their plants.